All right, so I'm going to continue with another example for how to write the formula equation, complete ionic equation, and the net ionic equation, okay? So in this example here, again, we need to write the products first, and this is, again, you can assume a double replacement reaction. So I'm going to switch the K and the Ba, so the first element in either compound, with each other. And I'm going to start by writing what elements are with each other now. So the K is going to be with NO3, and the Ba is going to be with SO4. Now, the next thing I have to do is make sure that these formulas, or these the formula compound is written correctly. So we have to do the crisscross with the charges. So potassium, again, you can refer to your periodic table. So here is potassium. It has a charge of +1. And we also have NO3, which again, we use that quite a lot. That has a charge of -1. So I'm going to go back to the notes here. So if this is +1, and NO3 is -1, if I do the crisscross, a 1 would go here and a 1 would go over here, and I don't have to write those, so we just leave it as KNO3. Now for the next one, we have Ba and SO4. So Ba, we look on our periodic table, that is right here, that has a charge of +2. SO4 is a polyatomic ion, so we're going to have to look here. SO4 has a charge of -2. So again, another easy one. Ba is 2 and SO4 is also 2. Again, normally we would put the SO4 in parentheses, but you can just simplify that to Ba SO4. So I can leave that one as is as well. Okay? So pretty straightforward there. The second thing I have to do is balance. So notice potassium, there's 2 here, and there's only 1 here. So I have to put a 2 in the front right here, which is good because now I have 2 NO3s, and there's 2 NO3s on this side. There's 1 SO4 here, 1 SO4 here, and 1 Ba on either side. So this is now balanced. Now, the next thing I have to do is determine if these are aqueous and soluble, or they are insoluble and will form a solid precipitate. Now, as I said in the last example, anything with NO3 in it will always be aqueous. Okay? So if you ever see NO3, that is always soluble and aqueous. Let's look at the next one, though. So again, when we're going to go use the solubility chart in just a moment. So you want to look at that second element, the anion that has the negative charge, so SO4. So I'm going to go to the solubility chart, and I'm going to find SO4, which is right here, okay? And SO4 is with Ba, and notice Ba is listed as an exception. So normally if a compound had SO4 in it, it would be soluble. But since this SO4 is with an exception, it is going to be insoluble and therefore form a solid precipitate. Okay? So now we are done with our formula equation. So now we're going to write the complete ionic equation. And again, anything that was aqueous up here, so these 3 things, you are going to disassociate, okay? So we're going to start with the K2SO4. So we're going to disassociate that. So we have the K plus the SO4. SO4 is a polyatomic ion. We have to write the charges on those. This is +1. And the SO4, that is -2. And we have to write AQ for aqueous for both of them. And then notice that there was 2 potassium here. So I'm going to have to put a 2 in the front. So that's this first one right here. Now let's move on to the next one. So plus, we have Ba and NO3. Again, disassociating those. Ba, we said earlier, has a charge of +2. NO3 has a charge of -1. They are both AQ for aqueous. Notice that we have 2 NO3s, so I'm going to have to put a 2 here. And then I'm going to do the arrow. So again, since I wrote a lot up here, I'm going to write this half of the equation below it, okay? Just because I can't fit it all just on this one page. So next one we have is this. So we have 2 of each ion. So I have 2 of the potassiums. Each of those is +1 and aqueous. Plus I have 2 NO3s. That's a -1, and that is also aqueous, okay? And then the BaSO4, we will not disassociate that because it is a solid precipitate. It is insoluble, so it will not disassociate. Okay, so all you did was you disassociated each one of these, which is a skill we have already learned. Now, the next part is writing the net ionic equation. So to show our work for that, you can actually show that for in the complete ionic equation. So you're going to cross off the ions that are the same on either side of the arrow. So I have a potassium ion here and on the other side of the arrow. And I have an NO3 on either side of the arrow, okay? Whatever's left over, that's what we write for the net ionic equation. So there's the SO4 plus the Ba, which is +2, will give you BaSO4, okay? If you want to write in parentheses, you can, but you don't have to. I did it right here, but you don't have to do that. And then S for solid, okay? So the net ionic equation is showing you the only things that were involved in that chemical reaction, okay? Now, let's say you have a situation where, let's say this one was also aqueous, hypothetically, okay? So let's say if it is that situation where you don't get any solid precipitate, nothing is insoluble, then what you would do is you would, for the net ionic equation, you wouldn't write anything. You would just write Na all spectator ions. So technically you wouldn't have to do the last step. You would only have to do these two, okay, if everything was aqueous, okay? So imagine like if that one hypothetically was aqueous, you would only do this part and this part. You wouldn't have to show any crossing out because you wouldn't have any net ionic equation. No reaction happened. You didn't get a solid precipitate form. If that happens, imagine you combine 2 clear solutions with each other and nothing happens. There's no color change, there's no nothing, okay? So if that happens, you would just write Na all spectator ions. That's gonna be pretty uncommon, okay, to come across a problem like that.